This is AQA Statistics, Continuous Random Variables 4. This video is about the cumulative distribution function for piecewise CDFs. Please pause the video to read the definitions. The cumulative distribution function can be abbreviated CDF, and we use the capital letter F of x to represent that cumulative probability. The CDF is usually found by integration of the PDF. We need to integrate the PDF from negative infinity right up to the variable value of x. F of x, the PDF, will only need to be integrated for regions of the random variable where f of x is non-zero. The derivation is more complicated for piecewise PDFs than it is for simple PDFs. Please pause the video to read through the example and to consider how you would answer the questions. This example is about Ahmed's journey to work, and we see the PDF is defined in two regions here. Firstly, from t equals 0 to 0.6 of an hour, so this actually should say hours here. The PDF is a quadratic curve, and here is the function for that quadratic. And then for t lying between 0.6 and 1.0, then we have this straight line graph running down and passing through where t equals 1. The first thing we have to do is to find the cumulative distribution function for Ahmed's journey time. In order to derive the cumulative distribution function, we will need to integrate each of these sections of the PDF. And here we show the integration that we'll need to do for t lying between 0 and 0.6. And there's an integration here that needs to be done for t lying between 0.6 and 1.0. Now, in this case, we're going to have a look at doing the integration without limits, and then therefore there will be constants of integration, and then figuring out what the constants of integration are by consideration of the following fact. So now it is a fact that the cumulative probability that t is less than 0 is equal to 0. Similarly, the cumulative probability that the time does not exceed 1 hour is 1. Now we can use each of these facts here to evaluate the two constants of integration that will arise when we do our integration. Note also we do require 4 regions. We must, to specify the CDF fully, we must indicate what's happening where t is less than 0, where the CDF itself is 0, and for t is greater than 1, the CDF is 1. Please pause the video and complete the integrations. Here we see that t squared has integrated to t cubed over 3, then the 18 up here in the denominator has become 54. Similarly, this bracket has become t minus t squared over 2, and then the constant outside the bracket has not changed in that case. So we've got two different constants here. Now, if we consider that f of 0 is equal to 0, then it must be the case that c1 equals 0. So that one doesn't take too long to work out, and on the next page we'll take a look at how we find C2. Pause the video to calculate C2. Now what we can do here is we can consider that where t is equal to 1.0 hours, then f of 1.0, that cumulative probability, so remember that represents the probability that t is less than 1.0, then that is going to be 1. So substituting in here, we substitute in f of 1.0 actually is going to be 1. 25 over 4 minus 25 over 8 plus C2. Rearranging that, we see that C2 comes to minus 17 over 8, and we can then carry that forward and substitute into the full CDF. Here we see the CDF fully specified in each of the 4 regions, and we can see that we've entered the values for C1, which was 0, and C2 here, which was minus 17 over 8. It's always a good idea to do a sketch of the CDF. So here is f of t, the cumulative probability, and here is t. Notice that when t is less than 0, then the cumulative probability is 0. When t is greater than 1, the cumulative probability is 1. The 2 curves join together nicely where t is equal to 0.6, and this is a requirement, of course. Moving on to the next part of the question, which is concerned with the median journey time and the upper quartile of the journey time. Now, we notice that the requirement is to show that the median journey time is 0.6 of an hour, and actually this was the point where we move from one PDF to the next PDF. So it does mean that we could use either of these two to show that f of 0.6, we need to show that f of 0.6 is equal to 0.5. And the obvious thing to do is to choose the simpler of the 2 functions. So we put in f of 0.6, put it in our function, and then we derive the value of 0.5 for the probability. So that does show that Ahmed's median journey time is 0.6 hours, and that is the point which is where we move from one function in the CDF to the next function. To find the upper quartile, we need to consider that the median value for the journey time was 0.6 hours, so the upper quartile then is going to be greater than 0.6 hours, and that means that we must look at this element here of the CDF to find the upper quartile. Substituting in, we find, and taking account of the fact that the CDF evaluated at the 3rd quartile is 0.75, here we substitute into the CDF that we already derived, and we finish up with a quadratic equation to solve. Here's our quadratic to solve. Now if we rearrange that and solve that quadratic equation, we do get 2 solutions. The lower of the 2 solutions, 0.72, lies within the range from 0.6 to 1.0, so that therefore is the correct answer, and this one here lies outside of the suitable region here of the random variable. So the answer is that the upper quartile is 0.72 hours. That completes this video. The next video is on the rectangular distribution.